Find dy over dx. For short, I would write y prime. Y prime means derivative of y with respect to x for this function, for this equation. Xy equals square root of x squared plus y squared. By the way, square root of x squared plus y squared, this is same as x squared plus y squared quantity raised to 1/2. Okay, so since we cannot separate y, we need to take derivatives of both sides with respect to x. That's called implicit differentiation because y is not defined explicitly here. So differentiate both sides with respect to x. So differentiate both sides with respect to x. So if we do that, in the left, let me write that, okay? I'm using prime for derivative with respect to x. So derivative of xy prime, derivative of xy, no sign means times here, equals derivative of this, x squared plus y squared raised to 1/2. Here in the left, we have a product, so we must use the product rule, uv prime. And as we know, when we have uv prime, that's u prime v plus v prime u. Okay, there is no other way out. That's the only thing we can do here. So using the product rule, we get derivative of x, 1, y plus derivative of y, that's y prime. And this is not 1 because y prime is dy over dx. That's what we are trying to determine for this question. V prime u is x equals. So we got here now something like, let me erase a little bit. This for me looks like u raised to 1/2 derivative. And when we have u raised to 1/2 derivative, where u is function of x, okay, it's a power rule, 1/2 u time u raised to 1/2 minus 1, negative 1/2 times derivative of this inside function u. So we will be using this power rule combined with the chain rule. So 1/2 u, which is this, raised to 1/2 minus 1, negative 1/2, times derivative of u, which is x squared plus y squared. So we still need to do derivative here, okay? This part is done with the derivative here. So let me copy. So we got here y plus y prime x, or x y prime, same thing. Here is 1/2 raised to negative 1/2. We can bring this to the bottom with 2 so that negative will be positive. And something raised to 1/2 means we can write square root times, no sign means times, inside here now derivative of x squared, 2x plus derivative of y squared, that's 2y times y prime. You may write here 2x times x prime, but x prime is 1. X prime means derivative of x with respect to x, so that's 1. That's why we don't write that prime. Okay, so pretty much we are done with the derivative. Y prime is here and y prime is here. Now we need to isolate y prime. But this y prime is inside parentheses. That means we must distribute this out from outside. So this junk times 2x, this junk times this. Okay, so this is y plus x y prime. I mean, this has not, this does not have any y prime. So for now, if you feel like it's writing a lot, we can say this one is just say u. Okay, that might help some people. Let's say this one for now u. Okay, you can keep writing, but this will help us simplify. So this is u times 2x, u times 2x plus u times 2y y prime. Okay, and we are trying to isolate y prime, and y prime is here and here, so we need to collect them in one side. So we can move this to the left, that means subtract this, and we leave here. So in the same way, we need to move y to the other side, means subtract y. Okay, let's do that. So we have x y prime, and we are bringing, means subtract u times 2y y prime is equal to, we have u times 2x already in the right side. I mean, times, you don't have to put dot, and subtract y from both sides. So now we can factor y prime out. That was the purpose of collecting in one side. So x minus u2y, or we can write 2uy or 2yu, doesn't matter, u times 2y or 2y times u equals, this is same as 2x times u minus y. Remember, u is this junk. Okay, then now we can finish the problem, because we can divide by this to isolate y prime. So y prime is 2x u minus y over x minus 2y u. Okay, now we need to write u, because u is just this. So that is y prime means dy over dx equals, or you may leave here and say where u is that. Okay, or you can simplify 2x times u. Okay, 2x times u is 1 over 2 x square plus y square, then you can cancel 2, so that's x over root x square plus y square. So this one is 2x, u is in fact x over root x square plus u square. So you may leave here just writing this and say where u is this. Okay, this one would work as a final answer if you say where. So let me finish, and then I can simplify if you like to simplify, and you can say where u is 1 over 2 root x square plus y square. Okay, you may live in that way. Okay, that's kind of final. Or you can write u as 1 over 2 x square plus y square, and if you do that, then you can simplify 2x times this, 2 to cancel, so we get x over x square plus y square minus y is y all over x minus 2y times u, again 2 to cancel, so y over x square plus y square. We can simplify further, which is not really needed, because if we combine these two, then we have this common bottom. If we combine these two, this should be common bottom, and we can cancel. So let me do that as well, since I simplified anyways. On the top, we need to combine this. We need to multiply second fraction by this. That leaves x minus y x square plus y square over this, and we have same thing over this, and these two bottoms cancel. On the bottom we got x times x square plus y square minus y, and this one might be the best answer, but this one works. Final.